Welcome to BST 690, Biostatistical Consulting and Applied Problems. This course will take place online through the 10-week summer semester. Modules will open at 8 a.m. on Tuesdays. All assignments will be due Mondays at 5 p.m. This will allow you to deal with any technical issues or any last-minute questions that you have on Mondays if you've worked over the weekend, rather than having to scurry to get things in on Monday morning. Each week there will be 2 new assignments that coincide with the content provided online. The topic-specific assignments should be completed first. This will help highlight some of the common issues that are often missed on the qualifying exam questions. And when you get to the qualifying exam question, try to spend no more than 1 working day on that old exam problem. That mimics what you'll have when you take the exam, roughly 1 day per question. You should be prepared to talk about your assignments and the exam problems on the subsequent Zoom session that week. The full syllabus is available on Canvas. Please read it. Make sure to take the syllabus quiz by next Monday at 5 p.m. What will we talk about in this class? So we won't simply just be doing old problems from the exam. You'll be learning a lot of techniques, tips, and tricks that will apply to any applied problem solving as a biostatistician or as a biostatistician consultant. So we'll talk about maintaining analysis documentation, presenting your data, so tables and figures, how to deal with missing data, reviewing hypothesis testing, p-values, multiple testing, and confidence intervals. We'll even do a simulation. We'll look at power and sample size. We'll review grant applications. We'll talk about answering the question for statistical consulting, and you will also create an abstract and a poster. When we talk about solving a problem, we really need to approach it in a systematic manner. So the essential question for this lecture is, what are the steps to approaching, analyzing, answering, and writing up a data analysis? As a biostatistician, you will deal with the spectrum of analyses, either being involved before data is collected, after data is collected, or on a secondary data analysis. But really, it's the same things that you're concerned about. What is the data? Where did it come from? What is the question to be answered or questions? What measure or outcome is going to be used? What statistics will be used to address that question? How do you make a statistical decision? And then how do you write up that decision in terms that non-statisticians can understand? So we'll group these into 4 phases. Phase 1 is stating the question. Phase 2 is deciding how to answer the question. Phase 3 is answering the question, and Phase 4 is communicating the answer to that question. Overall, there are 10 steps that go into these 4 phases. In stating the question, this is where you will evaluate and describe the data. So where did it come from? What is the sample? What are the variables? What types of variables are there? What are the observed statistics? You need to review the assumptions. Independence, variance, and sample size will be the main assumptions that you always need to pay attention to. Once you select your analytical method, there are analysis-specific assumptions that you will be concerned with, but you need to make sure that you always consider independence, your homogeneity or heterogeneity of variance, and then what sample size assumptions you're making. That will lead you to large or small sample statistical analyses. The third step, not the first step actually, is then to state your question. So you'll need the question in statistical terms. What is the measure? How are you calculating the measure? How are you collecting it? Is time involved? And what comparison or test is being made? Or is there a model? When you've completed phase 1, you'll move into phase 2, where you decide how to answer the question. So you'll choose a summary statistic associated with your primary outcome or variables of interest. You need to consider how random variation can affect that observed statistic. So what is the distribution? That is, are we assuming it's a normal distribution? And what that means is, under the null hypothesis, we assume equal mean. And under the alternative, we assume different means. Random variation would lead us towards the null. Non-random variability would lead us towards the alternative. So be aware about what you expect to see under the null hypothesis. And then you'll state a decision rule to answer that question. So which outcomes will lead you to retain the preference for the null hypothesis? What will lead you to conclude the alternative? That is your decision rule. In general, we're looking at an alpha level here of 0.05. Make sure you always specify your decision rule. Make sure you write it down and make sure that everyone knows who is reading it or listening to you what that decision rule was, so that it is clear what level of chance is being accepted for your alternative hypothesis. And then phase 3 is answering the question. So you'll notice phase 1 through 6, we haven't even used statistical analysis yet. We've certainly used some statistical methods to look at and summarize the data. We haven't actually addressed the question. In phase 3, that's where we answer the question. You'll want to calculate the statistic or fit the models. You'll want to make a statistical decision, and you'll want to state the substantive conclusion in words. So step 7 may, especially if you're model building, have a lot of back and forth. Remember, you always need to go back and check your assumptions with your statistic that you've used. Are there issues with variability? Do we have outliers? Is the data skewed? Is it normally distributed? So 7 and 2, you'll swap back and forth. Step 7 and 2. Making your statistical decision is wholly based on that decision rule. But that, of course, isn't the answer. The answer is not the p-value or the confidence interval. The answer is your interpretation according to your data. So what does it actually mean? And that's really key. It's not that we found them to be statistically significantly different. It's not that we found You'll also want to look at each predictor variable against your outcome and record all of those relationships. If you have a very simple question, this could be it. This could be your primary analysis. But if it's not, and it generally isn't, this will give you an idea of direction and strength before you fit a model. Significant relationships should lead you to inclusion of covariates. And then look out for changes in direction or strength of relationships once you fit a model. If you have a large univariate relationship and once in the presence of the model, the direction of that relationship switches, or you get very wide confidence intervals, remember that's an indication of potential collinearity. Do not forget your model diagnostics either when you get into model fitting. Once you've done your preliminaries, you'll want to describe the sample. So this is an example here of all the respondents by male and female, and then a comparison by gender for this NARCOMS data. And you can see here that you can have continuous and categorical data in the same table. If you are doing models, keep track of all model fits. Tables are super helpful for covariates and significance. You'll also want to keep track of fit statistics like your adjusted R-squared or your AICC or your BIC. Make sure to check assumptions of every single model. Anytime you remove a covariate, that means the assumptions need to be looked at again. Anytime you add an interaction, you need to go back and look. Justify your model selection and make sure you interpret all covariates, particularly when you're looking at odds ratios or if you're looking at slopes. Depending upon how you fit the model, whether you've used reference cell or mean coding, the parameter estimate is not the answer. You need to interpret. The difference between males and females is this, or for every 5-year increase in age, this is what happens to the outcome. Figures are very helpful at this point. Take a look at this figure, pause this video, and see if you can then actually determine what is happening here in this figure. It's very complicated, and if you can imagine trying to write this out by words or then show it in a table, it would be very difficult. See if you can sort of figure out what's happening here, and then in a later session, we'll talk about how to create a figure like this and what this figure actually means. For a manuscript, you'll want to write up the methods used based upon the results you ended up with, based upon the notes you took. So, for example, a main effect ordinal logistic model was utilized for each type of healthcare visit, adjusting for gender and current multiple sclerosis type, age, duration of disease, disability level, medication use, and employment. And then a note that income and employment were highly associated, so only employment was considered in the model. So go back now with this information and see if you can figure out what this figure is. You want to write up the results, include interpretations of variables and cite figures. Here's an example for how frequently people saw their MS doctor, what the associations were, and the interpretation of those, and actually what also was not related. Relapse or currently taking a DMT were more likely to have recently had an MS doctor visit or an MRI. Notice here it doesn't say and. So this isn't younger and female and more recently diagnosed. This is or. If they're younger or they're female or they're more recently diagnosed or they reported a recent relapse or they're taking a medication, they were more likely to have a recent visit. MS doctor visits were relatively consistent across all disability levels, with increases at higher disability, or lower disability was more highly associated with more recent MRIs. The summary or lay description should be geared towards the audience for which it is being provided. So if it's going into a multiple sclerosis specific journal, you can use more complicated language. If, however, it is going into a report for MS patients, then you need to restrict your language to, say, 8th or 9th grade level reading. And that will be determined by the audience to which you're presenting. Approaching the exam, and actually any analytical work, whether it be an abstract, a poster, a paper, or a presentation, start by reviewing the analysis documentation document on Canvas. This is a good place to start to keep track of everything. Prepare a template or adjust this template of your own for each question in the comprehensive exam and or each question that you have in your, or for each question that you have in your analysis plan. Save everything. Do not use temporary data files. The reason for that is if you have an incredibly long program, and I recommend that you have one program for data cleaning, one program for preliminary analysis, and then a different program for sets, and you have a problem, you have to run it from the beginning. So if you use permanent data files, it's easier to diagnose a problem and then only have to rerun one part of code. Comment your code meticulously. Print out or save as a PDF or as a Word file all of your output. This way, if you take a break or have to stop mid-question, you know exactly what you've done and where to go back to. And this is true of all analytical work. Doing things quickly or so-called on the fly is only going to come back and be problematic for you if you've made a mistake and you don't want to have to back all the way up to the beginning and start over. So this is how we'll approach every problem we encounter in this class, is you should get accustomed to running through the 10 steps, knowing where your data came from, what are the initial assumptions you make, what is the question at hand, go through phase 2 to really examine what your question is, what the variables you're using, how random variation will affect them. Then in phase 3, you're actually going to use data to answer the question. So make sure that you document your models or whatever it is that you're doing for the analysis, your statistical decision, so which hypothesis are you selecting, and then the decision in words. And then finally, step 10 is going to be where you bring it all together. Make sure to use tables and figures as applicable. That will really assist you in being able to adequately describe the results if you have things to reference. Again, while this is helpful for your exam, it's also a good habit to get into for all analytical work.